Bismillah ar-Rahman ar-Rahim. This is a statics class delivered by Dr. Qusay Al-Kaseasbeh from Mutah University on March 29th, 2020. Today, inshallah, we're going to start with shear and moment equations and diagrams. In this section, we will teach you how to draw the shear and bending moment diagrams. But first, let's start with the definition of beams and how they are classified. So when I say beams are structural members designed to support loading applied perpendicular or vertically to their axes. And they are, in general, long and straight and have a constant cross-section and might have a different cross-section. So this is the beam here, okay? This is a beam, and we call this beam as a simply supported beam, okay? So if you see, all the time the load comes this way. So the main job for the beams to carry bending moment bending moment. So this is the main job for the beams. And as I just mentioned, they are like horizontal structural members. The load is applied vertically to their axis. This is the longitudinal axis of the beam, and the load all the time comes this way. Okay, and they are classified as they have supported, okay? So we do have a simply supported beam as the one I just showed you right now. And when I told it's a simply supported beam, okay, it's just like a beam, it's pinned at one end and there is a roller at the other end. Okay, so here we do have two force components and here we do have one force component. So we call this as a simply supported beam. It's pinned at one end and roller supported at the other end. Okay, this is the definition of the simply supported beam. We do have many other beams. One of them is, okay, cantilever. It's just like fixed at one end and free at the other end. This is a fixed and this is the other end. So we call this as a cantilever beam, okay? It's kind of, let's say, a balcony in a building, يعني شرفة في بناية أو عمارة, okay? So it's here, it's fixed at one end and free at the other end, okay? And we do have overhanging beam. They are like this, guys, or continuous. Let's start with a continuous beam. This is a continuous beam. Let's say it's like this. This is a continuous beam. It has more than one span, and the span is the length between two supports. يعني السبان هو الطول بين two supports. هذا support هذا support. فإذا هذا span with this one is another span, okay? So this is, we call it continuous beam, okay? It's a continuous beam, okay? And we do have overhanging beam if this is just like this. So this, they call it overhang, okay? We don't want to go in details in that type of beams because this is not the main interest here in this section. Okay. To be able to design a beam, we need to know the shear force and bending moment diagrams, or bending moment, sorry, at each point along the longitudinal axis of the beam using the method of section. يعني to be or to design a beam لازم نعرف الشير والبندing moment بكل نقطة خلال هذا البيم، اوكي؟ طبعا هذا ممكن احنا زي ما as we did last time, we did use the method of sections. يعني take an imaginary section at any point, you can get it. Okay? Okay, so the shear and bending moment functions will be discontinuous at the points where we do have distributed load change, considered load or moment are applied. means شباب راح شوي إن شاء الله نشوف كيف ممكن نرسم الشير والبندing moment diagrams. راح نعملهم as a functions of x يعني راح يكونوا بدالة x as a distance. طبعا x is a distance, okay, from let's say the left point or the right point from the beam. Okay, so we'll see how or what does this mean. And the other thing here, guys, shear and moment diagrams, this is an important point here, for the beam provides a graphical descriptions of how the internal shear and moment vary throughout the beam's length. يعني راح تشوفوا كمان شوي كيف ممكن نرسم الشير ونحدد مثلا بالنقطة هاي كم الشير بالنقطة هاي كم الشير where is the max value. Same for bending moment diagram لأنه إحنا as a designer بهمنا نعرف where is the max shear and moment to design based on these informations. Let's take an example and see how we're gonna do that. So in this example we need to draw the shear bending moment diagrams for the shaft shown in this figure. Okay, the support at A is a thrust bearing and the support at C is a journal bearing. Okay, so here guys, this is, let's say this is a pin here, and the other point here, it's call it a roller. Much easier for you, يعني أسهل لكم من هاي المسميات. Okay. The first step, we need to find the reactions at these 2 points, at A and at B. So here we do have, let's say, AY and AX, but AX here will be 0 for sure. And we do have CY here. Okay. So if we take the moment at point C or A here, let's take it at point C. Okay, here. In this case, just here, the moment at point C equals 0, assuming it positive counterclockwise. We need to find the reactions, and I think you are mature enough to get them. So in this case, we have actually AY here. It will rotate this clockwise, so it's going to be -4, and 4 is this distance. AY plus this force will take the beam to the counterclockwise, plus 5, the magnitude of this force, times 2, and this one will equal 0. Solving this equation, we will get AY equal 2.5 kilonewton, and the direction as pointed here upward. Okay. Okay, to find CY, just take the summation of FY equals 0, assuming it positive upward. So we do have AY, which is 2.5, we just calculated, minus this force, which is 5, plus CY equals 0. CY, this one, guys, okay? So CY is equal 2.5 kilonewton, and the direction is upward as pointed in the freebird diagram here. Without doing the whole process here, الفورس at the midpoint، فأكيد هذا الرياكشن بده ياخذ النصف وهذا الرياكشن بده ياخذ النصف، half half، ولهيك أوجدنا AY is 2.5 و CY 2.5. This is for the smart people. Just doing that directly, you didn't need to do all this. يعني ممكن توجد reactions بطريقة أسهل. طبعا في حال إنه فعليا الرياكشنز هون is not the point. ما بدنا إحنا reactions فعليا، إحنا بدنا نرسم shear و bending moment diagram. Okay. We're done with the reaction 2.5, 2.5. Okay, right now, how many sections we need to take? Okay, so we got this force here, we got this force here, but we need to take two sections. Why? Because if you go this way, if we assume x comes from here, okay, تفرض x بتبلش من هون. طبعا x it's a value هون between 0 to L, which is 4 meters, okay? طبعا it might be here, it might be here. But at this point we have to take two sections. أول section هون وثاني section هون. طبعا ليش؟ لأنه حصل لنا تغيير بالقوة هون. At some point صار عندنا قوة جديدة. فكل ما يصير لنا تغيير بالقوة أو طبعا it might be distributed load, concentrated load، فلازم احنا ممكن يكون في moment هون، فلازم احنا ناخذ section بين كل قوة وقوة. Let's do that, okay? So, okay, let's assume we made an imaginary section here, and this section X, it comes from here. So this is X here, okay? So this is the cross section, okay? If we take a cross section, this is AY, and we got it, okay? And here, at the cross section, we have shear, we have moment, and as we did teach you last time, this is a positive shear, this is a positive moment. Actually, we do have normal force, but the normal force will be 0 here, so we don't need to do it, okay? Okay, right now, this cross section is X, it's from 0 to 2, okay? And in these equations, they will be valid, in this range from 0 to x is equal 2 meters. So right now here, summation of f of ay here is equal 0. So we do have ay, which is 2.5, it's upward, which is positive, minus v here, which is the shear, equals 0. If we do that, it's one equation with one unknown, so v here it's 2.5 kilonewton, okay? Taking the moment here at the point we made here, so the moment at this point, summation of moment is equal 0, assuming it positive counterclockwise. We do have here moment, which is this one, minus, because this is positive counterclockwise, minus 2.5 times x, because this distance is x, equals 0. Solving this equation, we will get the moment is 2.5x, okay, kilonewton meter. طبعا these two equations for the shear and moment diagram, they are valid within this range, within where x is greater than or equal 0, less than 2 meters, okay? Right now, we can draw the shear and bending moment diagram within this range. يعني نقدر نرسم الشير والبندing diagram. But let's continue to find the other part there. Okay. Okay. Here we need to take a section here like this, and x is from here, guys. طبعا أنت ممكن تفرض x from here, ممكن تفرض x from here, ممكن تفرض x from here. Okay. So, and this is the easiest one here. So make this x2, make this x1, here it's x1. So if we do that, يعني neglecting this is another way. طبعا هاي طريقة ثانية ممكن تشتغل فيها، ماشي؟ In this, doing this, we have this like this, okay? This is the one. So CY was 2.5, and here we do have shear, يعني we made a section here يعني عملنا section هون. We do have a moment. طبعا if you think about this it will be similar to this. طبعا أكيد هذا راح يكون وفعليا it's a symmetrical beam in geometry and loading, so it will be same. راح يكون نفس الشيء. So let's do this. So here summation of f of y equals 0, assuming it positive upward. So v here, it's a positive one, it's upward, okay? Plus this is positive, 2.5 equals 0. So v here is equal, minus 2.5 kilonewton. اوكي طبعا هون احنا بدنا نسمي هاي زي ما حكينا x2 وهاي اللي هون x1. اوكي عشان نكون واضحين. If we take the moment at this point here equals 0, assuming it's positive counterclockwise, what we do have? We do have 2.5, which is this one, times x2, okay, minus m, which is this moment, guys. This is m, okay, equals 0. So here we get m is equal here again, okay. M is equal 2.5 x squared. Yeah, sorry, x2. So right now, let me clean this up. So right now here we do have, in this here, we do have here V is equal this much, 2.5 kilonewton. We do have the moment is equal 2.5 x1, okay. In the other part, we do have V is equal minus 2.5 kilonewton. We do have moment here is equal 2.5 x2, and x1 is from here, x2 is from here, okay. So this is the way how we can get the shear and moment equations, and by getting this we can right now draw the shear and bending moment diagram. Let's do that. Okay, I told you here within this range we do have V is equal 2.5. It's a constant. So here 2.5, so it's a constant. This is the shear. So this is the shear. Just a minute, guys. Okay, this is the shear. Okay, here is positive, here is negative. لما نحكي عن هذا الأكسس. Okay. So we start with V is equal 2.5. Okay, along this distance اللي هي 2 meter. Okay, right now keep this like, or keep this like this. Okay. Okay, and from the other side, let me pick a different color. From the other side, we told you this is x2 and comes from 0 to x is equal to. So here, V was minus 2.5. And this one should be connected, okay? Should be connected. I'll teach you different techniques. راح أعلمك طرق ثانية كيف أنت ممكن ترسم الشير والبندنج مومنت diagram بطريقة أسهل. ف this one, this is the shear. هذا بوزيتيف وهذا نيجاتيف لتحت. اوكي، او خلينا نحكي هيك. let's do it the other way. This is positive, this is negative. Shear. Okay, so right now what about the moment? In the moment here we told you the moment is equal 2.5 x1. So here x is equal 0, and here x is equal, because this is at 2 meter, equal 2.5 times 2, it's 5. صح؟ 2.5 ضرب 2. الآن from the other side اللي هي x2 اللي هي هون يا شباب. اوكي، كمان نفس الشيء 2.5 times x is 0 here, x is 5 here. So this is the moment diagram. Okay, now I'm gonna teach you different ways for how to draw shear and bending moment diagram, but this is the basic way. يعني هاي الطريقة الأصيلة هنحكي أو the general way إنك تاخذ sections وتطلع equations وتعوض. اوكي، الآن هون moment طالع معهم بالطريقة هاي في الاريا، إذا بتعوض x من هون يطلع معك نفس النتيجة. أنت it's up to you. You are free to go يعني من أي direction you want. So let me clean this up right now, guys. If you think about this, now like this. Okay, let me pick the red one. So we do have 2.5 kilonewton here, اللي كانت AY. وhere is the shear. So we're gonna go up 2.5 بنفس هذا المقدار. ماشي؟ بنفس هذا المقدار. الآن if you go this way ما عندك أي load. There is no load here. So you will keep constant. راح تمشي بنفس الخط ما عندك أي load. Okay. At this point طبعا هاي القيمة اللي هي 2.5 شو. Okay. اللي هي هاي القيمة. Okay. At this point 2.5 minus 5. هون 2.5 أنت you go down راح تنزل لتحت 5. Okay. 5 كيلو نيوتن. هون 2.5 minus 5 راح تطلع عندك minus 2.5. هاي القيمة minus 2.5. اوكي، الآن كان نفس الشيء you're gonna keep straight لأنه أنت ما عندك أي load بالمنطقة هاي till this point. At this point you have a load upward 2.5. أنت هون minus 2.5 هون بتصير عندك إيش؟ minus 2.5 plus 2.5 بتصير عندك إيش؟ 0. So this is the shear. نفس اللي رسمناه هناك بالمعادلة. اوكي. Now as I mentioned to you إنه W which is the load intensity. اوكي، اللي هي كتابة اللود بتتذكروها بالdistributed load. إذا كملناها فإحنا نطلع الشير، وإذا كملنا الشير نطلع المومنت. التكامل معناته الاريا under the curve، يعني قديش area under the curve. فإذا كملنا الشير هون this is the area under the curve بيطلع معي المومنت. فمعنى الكلام if you قديش الاريا هون this is a rectangular. okay, this is a rectangular, it's a positive rectangular. okay, هون كم الاريا هون it's 2.5 times 2 صحيح. فالآن it's gonna be ايش؟ positive. ليش positive؟ once again شباب load intensity this is shear this is moment. الآن if we go this way فإحنا بنعمل تكامل integration. if we go this way فإحنا بنشتق. إذا اشتقينا المومنت شو بعطينا؟ shear. وإذا اشتقينا الشير شو بعطينا؟ اللود انتنسيتي. المشتقة شو هي؟ هي السلوب. المشتقة الأولى هي السلوب. اوكي، الميل. فبهاي الحالة the slope of the moment here is the shear. يعني السلوب هون كم بتكون قيمته؟ 2.5 أكيد. let's see خلينا نشوف let's take a section. السلوب هون اللي هو 5 minus 0 over 2 minus يعني 5 minus 0 over 2 minus 0 وهاي القيمة تطلع عندك ايش؟ 2.5 طبعا positive واللي هي قيمة الشير هون. اوكي؟ this okay. ف we're gonna go from here 0 لأنه هون عندنا we have a pin, so المومنت على البن 0 from 0 to 5 positive. Okay, this value is 5. Okay, الآن this value is minus, so بنقول 5 minus this area. This area is how much? It's minus 2.5 times 2 اللي هي minus 5. ف 5 هون minus 5 يعني 5 minus 5 وهاي ال 5 هي الاريا من هذا الشكل. طبعا ماينس لأنها حكيناها لأنها هي بالماينس. 5 minus 5 is gonna be 0 والسلوب هون شو راح يكون؟ اللي هو minus 2.5 which is the shear. اوكي، وهو واضح انه ايش؟ minus, it's downward this way. ف this is another way انك تحسب هون الشير وبعد هيك تحسب الاريا under the shear وهي فعليا راح تكون المومنت. طبعا بيهمنا شغله، if the load here يعني زي ما حكينا هو مشتق، ما هو اللود الشير تكامل للود والمومنت تكامل للشير. الآن إذا كان اللود constant بده يكون الشير linear function، وإذا كملنا اللينير function شو بده يصير؟ second degree. هون كيس لا، إحنا عندنا اللود هون بالمنطق هاي وهاي زيرو. إذا كملنا الزيرو بعطينا constant اللي هو هذا constant function. اوكي، اذا كملنا الكونستنت اعطينا اللينير. راح نشوف امثله ثانيه يكون فيها لسه second degree و third degree. ماشي، بدك تنتبه لهي القصه وراح ناخذ examples ان شاء الله ونشوف كيف ممكن نعمل هاي الاشياء. This is one example. Let's do another example. In this example we do have a simply supported beam which is this one, guys. Okay, this is a simply support because this is a pin, this is a roller loaded with a triangle distributed load. Okay, this is a triangle distributed load and this point is 6 kilonewton per meter and the length is 9 meters. For this we need to draw the shear and bending moment diagrams for this beam. First, we need to calculate the reactions. We do have two reactions here, but actually let's call this AX, this is AY. We do have another one here, let's say this is BY. Okay, AX will be 0 because taking the summation of f of x here we do have just AX, so it's going to be 0. So let's take the moment here at A. So assuming the moment at A equals 0, assuming it's positive counterclockwise, we do have what is the resultant for this force. It's going to be 1/2 times the base, which is 9 meter, times 6 kilonewton per meter. So this one is going to be 27, okay? So this one is going to be 27 kilonewton. And it's located 1/3 from this side, which is 1/3 of the 9, which is 3 meter. Let me fix it here. Okay, this is 3 meter and this is 6 meter because this is 2/3 of the 9. Okay, the total is still 9 meter. Okay, so in this way the moment is going to be minus 27, which is the equivalent force, times 6 اللي هو هاي القوة يا شباب times the distance اللي هي 6 till this point. طبعا minus لأنه it's going to rotate the beam clockwise. And we do have this, which is plus 9 by equal 0. So one equation with one unknown by. So by here is 18 kilonewton and the direction as indicated in the Hibbeler diagram upward. Okay, then taking the summation of f of y, assuming it's positive upward, we do have ay minus 27, the equivalent force here, plus By, which is 18, equals 0. So Ay is equal 9 kilonewton and the direction upward. طبعا كمان يا شباب هون الآن هاي القوة بعيدة من هون ثلث ال ومن هون كم؟ ثلثين ال، فهان راح ياخذ الثلث ال واللي هو 27 تقسيم 3 واللي هو 9 واللي قبل شيء أوجدناه، وهون راح ياخذ ثلثين ال واللي هو 27 times 2/3، فهي تطلع معي 18 واللي هي أوجدناها من هون. فيعني you can check your answer quickly. Okay, right now we're done with the reactions. So we need to take how many sections in this way or in this example? One section. Why is one section? Because here it's a distributed load and it's uniformly changed. Okay, so we are just need to take one section. So you can take the section anywhere you want. Okay, so let's say we took it, and we might take this side, which is the left side, or the right side, but the left side is much easier because if you go this one, you need to make a rectangular and triangle. So let's go with the left side here. Left side part or segment. So in this way, we do have, I want to just try different color for the load. So we do have the beam, and this is the load. We do have nine kilonewton here, and we do have Y here. We don't know this Y, and this is X, guys. Here we do have V, which is the shear, and we do have the moment. So how we can find an equation here for the shear and bending moment diagram, or how to draw them? So right now we need to know how much this point, because we don't know how much this to find the equivalent force as we did here. So use similar triangle. Just let me clean this up to use it for the similar triangle. Okay. Okay. I think we're done. So here, guys, if we take a section, let's say here, and we made the section here. So this is the smaller triangle, and with different color, this is the large triangle. So if this value is 9, okay, and we do have this point is 6 kilonewton per meter, okay? So, and this one here is X. It's X, just X, okay? And what about this? This is 9 minus X. Okay, we don't care about this right now, but just I want to show you. Using similar triangles, we do have 6 over 9 اللي هو هاي النقطة على المسافة هاي كلها is equal this value, which is we're gonna call it Y, because this point is XY. It's XY. So this one is Y over X. And so this one is going to be 2/3. So Y is equal 2/3 X. So this value here is 2/3. Okay. To find the equivalent for this one here, we find Y times X times 1/2. Okay. Here it's 1/2 times X, which is the base here, which is this, times Y, which is 2/3 X. So this value is equal to x squared over 3. Okay. Actually, it's 2/3 of L here, and L here is x, so the distance here is 2/3 x, and from the other side is 1/3 x. Okay, right now, okay, for this sketch, once again, the equivalent force is this much, and it's 2/3 of x from this side, 1/3 of x from this side. So if we take the summation of Fy here for this part is equal 0, assuming it's positive upward, we do have 9 kilonewton, which is the reaction here, minus x squared dividing by 3, okay, minus v, which is here, equal 0. So if we do solve this, v is equal 9 minus x squared over 3. Over 3. So this is the shear, okay? And if we take the moment about this point, we do have summation of moment here, guys, equal 0, assuming it's positive counterclockwise. We do have m, which is this value, it's positive, okay, and this one is going to be positive. The equivalent here is a plus x squared over 3. This is the force magnitude, هاي قيمة القوة, times how much? x over 3. Okay, مسافة resultant عنها هو. We still have one force here, which is minus 9x equal 0. So the moment here is equal 9x minus x cubed dividing by 9. So this is the moment along the longitudinal axis of this beam, and this is the shear. One thing to be noticed before we go and draw the shear and bending moment diagram, if you look at this, what is the relationship between this and this? If you integrate this, إذا عملت تكامل لهاي العلاقة، شو راح تكون 9x minus x cube dividing by 3 times 3 اللي هي هاي. فلما نكامل الشير بنطلع ايش؟ المومنت. كاملنا الشير هون نطلع المومنت، ولما نشتق المومنت بنطلع شير. ونفس العلاقة بين الشير والديستريبيوتد لود نفس الشيء. إذا اشتقينا الديستريبيوتد لود بعطينا سوري، إذا كمان الديستريبيوتد لود بعطينا الشير، وإذا اشتقينا الشير بعطينا distributed load. Let's go and draw right now the shear and bending moment diagram. Let's see how is that. Okay, so here is the beam. This is 9. This is 18. This is the equations for the shear, or equation. It's one equation, and this is the equation for the moment. Okay. So here 9 minus 0 dividing by 3, 9. Before doing this, this is a distributed load. It's a linear function, صح؟ So shear لازم يكون شو؟ second degree function. لأنك إذا بتكامل linear بده يكون second degree. والمومنت شو لازم يكون؟ third degree. Okay؟ فهون it's gonna be 9 if you substitute here, it's going to be okay. Substitute here. Doing like this, هون substitute like here, it's going to be 9 minus. كم هون? It's 9 meter. Okay, so 9 minus 9 square over 3, 9 square اللي هو 81 dividing by 3 27, so 9 minus 27 عندنا minus 18 وهون it's minus 18 تصير 18. Okay. طبعا ليش هو concave down؟ لأنه هون the load is downward. إذا اللود downward فبده يكون الفانكشن أو السكند ديجري فانكشن concave down، يعني concave down مقعر للأسفل. اوكي، إذا كان هذا upward this way upward بده يكون العكس، بده يكون ايش؟ concave something like this. يعني I'm not sure how it's gonna be but it's gonna be concave up. okay. in this case هاي معادلة رياضية، it's a basic يعني math. ولو عوضت بالمعادلة هاي لازم يعطيك شكل هذا الشكل. اوكي، بس انت you can't يعني do it everywhere. How to find this value here؟ طبعا هون كمان قبل هيك يا شباب، هون عندك okay how we can find this point؟ هون shear is equal 0 so بس اعمل هذه equate this to 0 اللي هو 9 minus x square over 3 equal 0. طبعا راح يطلع معك two values اللي هو هاي راح تكون لنا اللي هي x أو 27 is equal 0 راح تطلع أكيد يعني it's 5.2 minus 5.2 وبناخذ البوزيتيف لأن it's a distance فراح تطلع معك هاي القيمة. لو عوضت هاي القيمة هون لازم تطلع معك صفر. أوكي ماشي. الآن for the moment as I told you this is going to be 3 bending 3 degree function. لازم يكون concave down. اوكي concave down طبعا انا كيف بعرف انه concave down كمان؟ لانه هون عندي السلوب هون، السلوب هون يا شباب لازم يكون ايش؟ الشير هون، والشير هون عندي ايش؟ بوزيتيف، فالسلوب كله ايش هون؟ بوزيتيف. هون at this point السلوب بصير عندي ايش؟ قيمة الشير هون، مش قيمة الشير هون ايش؟ نيجاتيف، فالسلوب بكون نازل. اوكي؟ فالسلوب هون بكون نازل. طبعا كونكيف داون حاكين لك لانه فعليا هذا كونكيف داون، ونفس الشيء لانه فعليا هذا متناقص فكمان هذا كونكيف داون. هيك this is the math. okay the maximum value of the bending. طبعا احنا هون لو عوضنا البندنج مومنت دايجرام مباشره من هون شباب من المعادله اللي اوجدناها تطلع معنا هاي القيم، يعني عوض تطلع معك هاي القيم، هاي راح تطلع معك الماكسيمم فاليو. عوضت هاي القيمه في المعادله هاي راح تطلع معك القيمه اللي هي 31.2. عوض هاي تطلع معك 30.2. this is the maximum value. دائما الماكسيمم مومنت at V is equal 0 لما يكون الشير is equal 0. لما الشير equal 0 بده يكون المومنت ماكسيمم. فاهمينها هاي؟ this is an example. another example. هون it's really hard to get the يعني نستخدم طريقة الاريا. الاريا هون صعب تحسب الاريا because this is a parabolic يعني قطع مكافئ وهي الاشياء، وهون صعب تحسب الاريا فاحنا بنرجع هون للايكويشنز او يعني بنحاول نعرف يعني بالماث انه فعليا هذا is gonna be decreasing function وconcave down لانه this is down، وهذا كمان بده يكون it's a function here يعني up here down here وconcave down لانه فعليا هذا decreasing. يعني هاي بدك تعمل ريفرش للماث بالنسبه لك. اوكي let's take another example on this. Okay guys, let's take this example. In this example page example 7.8 page 373 we need to draw the shear and bending moment diagrams for the cantilever. This is a cantilever, it's fixed here at B and free at A. So first of this we need, or the question is, do we need to find the reactions here? No, because we can take the section here, the first section, and the second section here from this way, and we don't need to find the reaction. So don't waste your time finding the reactions here because it's not necessarily to find them. So here we need, as I mentioned, we need to take two sections, one here, one here. Why? Because here at this point the load is changed, so we need to take another section. Okay. And this one, let's take the first section from here. So the section will be like this. 2 kilonewton, which is this one. And this is going to be X from here. We do have shear here. This is V. We do have a moment. So V here, or let's, if we take the summation of Fy equals 0, assuming it's positive upward, we do have minus 2 kilonewton. Okay, what's going on with this pen? Okay, minus 2 kilonewton minus V equals 0. So V here is equal minus 2 kilonewton. Minus means it's going to be like this. It's upward, not downward, okay? But we will keep it minus here like this, but the direction is like this, okay? يعني راح نخليها مثل هيك ونعوضها دائما ايش؟ بالماينس. Okay, the moment here guys, is equal summation of the moment equals 0, assuming it's positive counterclockwise. It's going to be minus 2x. It's positive here. It will end up with minus, but here is positive. Positive m equals 0 because this is also, so here m is equal, as I told you, minus 2x. طبعا it's kilonewton meter. شباب أنا كيف بعمل؟ in this case المومنت بهذا الاتجاه واللود باخذ بهذا الاتجاه، ففعليا المومنت هذا راح يكون ناقص هذا. فعليا this is going to be m minus 2 kilonewton. نفس الشيء بالنسبة للشير. الشير كانت هاي تنتهي بنفس الاتجاه، فأكيد في راح تكون ماينس هاي. طبعا هاي بالممارسة إن شاء الله you will get it. Okay, so we find the shear and moment equations for this section اللي هو it comes from here to here. So x here it's 2 from, let's say here, from 0 to 2. And it's okay if you say it's equal to. The other section, so we're done with this. The other section will be like this, guys, if we're going to take it like here. Okay, so the other section is going to be like this. This is 2 kilonewton. And we do have solid load here. So here, this is 2 meter. This is x. So this is 2 meter. This is x. Here, this is 1.5 kilonewton per meter. So we do have shear here. This is V. We do have moment here. Okay. Before doing anything here, the equivalent force here is equal 1.5 times x. ليش؟ ارتفاع هون اللي هو هون 1.5 يعني خلينا نحكي طول بعرض. So العرض هون اللي هو الارتفاع 1.5 والطول هو x. اوكي، تبعد من هون x over 2. اوكي، لأنه هاي هي فعليا x بس هاي distance. So here if we take summation of Fy is equal 0, assuming it positive upward, we do have minus, يعني هون V راح تطلع معنا بالضبط، يعني that's what I'm gonna tell you إنه كيف ممكن أوجدها مباشرة. V هون راح تطلع معي V is equal minus 2 minus 1.5x هيك راح تطلع معنا. كيف؟ لأنه هاي في بهذا الاتجاه، هاي بنفس الاتجاه وهاي بنفس الاتجاه. لما هاي بدها تكون معهم، يعني لو بدك تكتبها كمعادلة هتكون -2 -1.5x minus b equal 0. ونقول v على الجهة الثانية بتصير عندك هاي المعادلة. هذا اللي بقصده أنا بهاي الفكرة. It's okay. بالممارسة راح تحصلوها، مش it's not your time right now. بس أنا بحب أعلمك إياها حتى أنت تكون عارف كيف ممكن توجدها. Okay, so the moment right now, taking the summation of moment, summation of moments equals 0, assuming it's positive counterclockwise, we do have the moment itself, which is this one. فهذا بنفس اتجاهه، فراح يطلع معنا اللي هو minus 1.5x، هاي قيمة ال resultant force هون times x over 2 اللي هي المسافة هاي. اوكي، كمان minus اللي هي 2، هاي 2 هون، المسافة هاي بتكون 2 plus x 2 plus x equal this is m. طبعا كيف؟ هاي المعادلة صحيح ماينس ماينس، هاي بتكون بوزيتيف هون بوزيتيف هون بوزيتيف مومنت، بس تنقلهم على الطرف الآخر هون بده يصيروا بهاي الطريقة. يعني أتوقع أنكم smart enough to do this. Okay, right now we got the shear and moment here, the shear and moment here. So let's go and draw the shear and bending moment diagrams. Okay guys, this is our beam here. Okay, so as I told you, this is going to be different. So here we find the shear is equal -2. So the shear is a constant here is -2. طبعا constant ليش؟ لأنه هون ال W is 0، فهذا بده يكون constant. والbending moment هون بده يكون linear. Okay، هون وجدناها -2. Okay. And on this side we find it -1.5. Just a minute, guys. Let me get back to the equation. Yeah, we got it here. So V is -2 minus 1.5x. So, but x comes from here. This is x, okay? It's starting from here, Shabab. So if you apply x is equal 0 here, so you will get V is -2. وهذا صحيح. ماشي؟ الآن -1.1 -2 minus هون اللي هي this كمان is equal, so this distance is 2, so -2 minus 1.5 times 2 اللي هي -3 -2 -3 اللي هي -5. فمن هاي الطريقة أنت تقدر تعرف إنه فعليا هون الشير أو الفورس الرياكشن عند الفيكست اللي هو 5 كيلو نيوتن حتى أسكر الشير هون. لازم يقفل معك الشير والبندنج مومنت، لازم يقفلوا معك. شايفين شباب؟ لازم يقفلوا معك. طبعا in this way this is a linear here. Okay, why? Because we do have the distributed load here is a constant function. كامله بيطلع معك linear، كامله بيطلع معك ايش؟ second degree. وعارفين هون انه فعليا راح يكون المومنت concave down. Okay. Okay, for the moment here, without it, let's say this is actually -2x, so this is -2x is 0 here, so it's going to be 0. لازم يكون 0 هون. طبعا المومنت لازم يبلش ب0 ويسكر ب0. so هون -2 times 2 بتكون -4. هذا بده يكون linear، هذا خط مستقيم يا شباب. اوكي، هون ببلش انه يكون ايش؟ it's second degree. ليش second degree؟ لانه هاي constant، this is a linear، this is second degree concave down قاع للأسفل، لأنه هذا it's a decreasing function وهذا إيش للأسفل. ف this much here it's gonna be, so here if we using the area, so this area is equal -2 times 2 وهي اللي -4 minus، لأنه هاي كمان إحنا كله بالماينس minus هون how much this is a trapezoidal شبه منحرف. قديش مساحة البيزز؟ بتكون 2، طبعا كله هو ماينس فعليا، -2 plus minus 5 اللي هي هاي وهاي dividing by 2. الارتفاع كم هو هون؟ ارتفاع 2. ففعليا just a minute guys. Okay, yeah, this by this is going to be minus 7. Okay, الاريا هاي minus 7, so minus 4 هون minus 7 minus 11. فانت تقدر تعرف المومنت هون على الفيكس ان مومنت فعليا انه هو ايش؟ minus 11. Okay, so this is the way, and the other way to use the equation that we just got it in the here. Okay, طبعا مرة ثانية شباب، هون عندك سوري، هون عندك اللود كان 0، فالسلوب هون طبعا 0، السلوب هون it's 0. اوكي، ما فيش تغيير على واي اكسس. وهون عندك السلوب ايش؟ minus 2 اللي هو قيمة الشير، يعني فأي نقطة هون تكون minus 2. هون عندك السلوب اللي هو هون، السلوب اللي عندنا هون اللي هو فعليا 1.5. قيمة الديستريبيوتد لود هون، قيمة الديستريبيوتد لود اللي هو ماينس 1.5 طبعا لأنه هو داون وورد. أوكي، وقيمة السلوب هون هي قيمة الشير أي نقطة هون. فهاي العلاقة بين الشير والديستريبيوتد لود والبندنج مومنت diagram. Thank you guys. I would recommend you to practice more examples. يعني حاول تمارس أكثر على الشير والبندنج مومنت diagram لأنه مهم جدا بحياتك الهندسية. Well, thanks for watching. Please let me know if you have any questions. You can email me or chat with me on Microsoft Teams. ويعطيكم العافية.